Okay, just what it says, putting it all together. Okay, we kind of went backwards, learned how to graph the lines, learned how to shade, learned how to find the feasible region, how to find corner points, then how to test corner points. Then we went backwards and figured out how to take a word problem and find all those things. And now we're going to do it all. So first off, we're going to read the problem carefully. Identify the constraints. Use the table. Determine the objective function z equals. Graph it. Find the corner points. Plug in and test. So, example 1. Small firm builds 2 types of garden sheds. Type A, type B. Let's let X be A and Y be B. Just keep it alphabetical. Here's shed A, and this is shed B. Now machine time. It says type A requires 2 hours of machine time. So we just put 2 under machine time. And 5 hours of craftsman time. So 5 hours of craftsman time. B requires 3 hours of machine and 5 hours of craftsman. Each day there are 30 hours of machine time available. That's it. That's all they have in the day. So it has to be less than or equal to that amount. They can't go over. And same thing with craftsman time. It's 60 hours. And that's the maximum. They can't go over that. So the amount of time spent has to be less than or equal to 60 hours. Profit, revenue, on shed A is $60. On shed B it's $84. Now remember, we've had problems where revenue is the first sentence and sometimes where it's the last sentence. You want to look for words like revenue, profit, okay, something like that. And remember, this is going to be where the z function, z, comes from. So constraints. We have 2x plus 3y is less than or equal to 30. We have 5x plus 5y less than or equal to 60. Our objective function is z equals 60x plus 84y. Now we're going to graph our lines. So what I need to do now is take both of these and rewrite them in y equals form, y inequality form. So I'm going to move my 2x over by subtraction and divide by 3. So that's going to give me y is less than or equal to, remember it's going to be negative 2x, right? But I divide by 3. Plus the 30 divided by 3, which is 10. Don't forget, it already shows you here. See how we're already only in the first region? But we still should always put x greater than or equals 0, y greater than or equals 0. Even though it's kind of a given in these real-world problems, you still do that. So right there you have your lines. Those are your axes, basically. So we're going to graph 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, negative 2/3. I'm going to go down to 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And it's going to be a solid line, like so. Then we're going to test 0, 0. 0 is less than or equal to 10, true or false. That's a true statement, which means we're going to shade down toward 0. Let's do our next one. Solve for y. I'm going to move the 5x over and divide by 5 in front of the y. So it's going to give me y is less than or equal to negative 5 divided by 5x plus 60 divided by 5, which is 12. Simplified, that's just negative less than or equal y is less than or equal to negative 1x plus 12. But we can think of it as 1, we can think of it as 1 over 1, because that's what we're going to do. We're going to go down 1, right 1. So we're going to start at 12 as opposed to 10. That's going to be right here. And we're going to go down 1, right 1. Now notice we have an intersecting point right there. Now we're going to test. 0 is less than or equal to 12. True or false? Well, that's true. Which means we're going to shade everything under that line. So now we got to look for where is our feasible region. Well, you can start wherever you want. I start 0, 0. Okay? And that's one of my corner points right there. 0, 0. And now I'm just going to kind of like ride along until I hit my first intersection. That's going to be right here. Because it's got to be under there. We're not going to go all the way to the blue. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 0. And then I'm going to come up here to this point, which is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. And then I'm going to ride up the blue line, because I got to stay underneath the blue line here. There's my other point, which is at 0, 12. Come down here. This is my feasible region right here. So that's 0, 12. Now I'm going to test these 4 points and see what I get for a z-score. Well, if I plug in 0, 0, 60 times 0 plus 84 times 0, it just gives me 0. Now a good way to maximize profit. 12, 0, I need to do 60 times 12. Okay? So I do 60 times 12. So 720. Plus 84 times 0. So that's just 720. Now I'm going to do 60 times 6 plus 84 times 6. Hopefully you can see where this is going. 60 times 6 is 360, plus 6 times 84, which is 504, plus 360 is 864.
This looks slightly different because I realized I made a mistake, and I made this a 12 instead of a 10. So the only one left to evaluate is 0, 10. 60 times 0 is 0. 84 times 10 is 840. So we're looking for the maximum, which is right here at 6, 6. Which means, back to our original problem, 6 of shed A and 6 of shed B.
Printed weird. That should not have been on the first page. So example 2. You are a professional organizer and you need to buy some filing cabinets. You know the cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Okay? So let X be X. Hey, just get creative here. And let Y be Y. Now, we can do each one or just go right on down. So here's cabinet X. And here's cabinet Y. Well, it says it costs $10 per unit. Okay? So cost, $10. It requires 6 square feet of floor space and holds 8 cubic feet of files. Cabinet Y, on the other hand, costs $20 per unit. Requires 8 square feet of floor space and holds 12 cubic feet of files. Now, you've been given $140 for this purchase, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. So where is 72 going to go? Well, that's under square feet. Cost, since we're talking about $10 and $20, that goes here, $140. The office has no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage value? Now notice, we don't have anything saying the maximum amount of volume that can be in the room. So you're like, well, where did this go? Where's this information right here? We have nothing here. Okay? Well, that is going to give us our z-score. Because instead of maximizing cost or profit, and usually looking for that word profit or revenue, now we're maximizing storage value. So that is going to go into our objective function. So our constraints are 10x plus 20y. Again, we can spend up to $140. And then we have 6x plus 8y. Again, less than or equal to, that's the maximum amount of space we can do. And of course, we always have our classic greater than or equal to 0, y greater than or equal to 0. And then our z is going to be 8x plus 12y. Because that's the volume per cabinet. So I'm going to rewrite these and solve for y. Kind of short on room here. So I'm going to move the x over by subtraction and divide by 20. So I'm going to get y is less than or equal to, remember, negative 10 over 20 is really just negative 1/2 x, plus 140 divided by 20 is 7. Over here, we're going to move the 6x over. So we're going to have, I'll show this in 2 steps. 8y is less than or equal to negative 6x plus 72. Then we're going to divide everything by 8. Which gives me y is less than or equal to negative 3/4 x reduced plus 9. Okay, so now I go and, 72 divided by 8 is 9. Had a little visitor. So we've got the first one, 7. 1, 2, 3, 4, 5, 6, 7. Right there. Down 1, right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2, and so forth. Keep on going. The more times you do this, the more accurate it is. Solid line because it's less than or equal. Now I'm going to test 0, 0. And I get 0 is less than or equal to 7. True or false? Well, that's a true statement, so I'm going to shade everything underneath here. Go to my next one, 9. So that was at 7. Go up 2 more to 9. Different color here. 9. And go down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Looks like a hit there. Then 1, 2, 1, 2, 3, 1, 2, 3, 4. So a little bit there. So when I draw this line, I'm going to test 0, 0. 0 is less than or equal to 9. That's a true statement. So this time I'm going to shade everything under here. So now, my corner points, once again, I like to start at 0, 0. It's a funky looking comma. Looks more like a hello. There's my 0, 0. And I'm going to kind of go until I hit a point, which looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, 12, 0. And then I'm going to come up here to that point right here, which looks like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 8, 3. And then I ride out to here at my 0, 7. Come back down. There is my feasible region. Right there. And I'm going to test my corner points. So obviously, once again, 0, 0 is not going to maximize anything because that gives me a big fat 0. 8 times 12 is 96. Plus 12 times 0 is 96. 8 and 3. Well, 8 times 8 is 64, and 64 plus 3 times 12, which is 36, is 100. Oh, that's more. And now we're going to do 8 times 0 is 0. 7 times 12 which is 84, right? So this time, unlike the last one, where the one out to the right on the x-axis ended up being the answer, this time we have a winner at 8, 3. So what does that mean? Well, we go back to our x and y, and we're talking about cabinets. So that means we're going to get maximum volume from 8 x cabinets and 3 y cabinets. And that maximizes our volume in this situation. And there you go. Putting it all together.